Hello and Namaste. In continuation with the Z transform, after the detailed discussion on the different properties of Z transform, we are going ahead with a set of different questions altogether. Now this session onwards, I am going to put the question here in the first slide so that you will be able to understand what all type of different properties or different questions we are going to deal with the Z transform. Now these are nothing but the standard functions for the Z transform which will useful for the further upcoming session. This will also be as one of the question can be considered. So Z transform of a to the power n, Z transform of -1 to the power n, e to the power at, e to the power minus at, and a to the power n minus 1. This type of questions we are going to deal it for this particular session. Now Z transform of a to the power n is summation of a to the power n z to the power minus n. N is moving from 0 to infinity because of the definition of the Z transform, which is nothing but this a to the power n into z to the power minus n can be written as a by z to the power n. N is moving from 0 to infinity, and if n is greater than or equals to 0. Now that means what is it? 1 a by z. Suppose we are going to start putting the values of n equals to 0, 1, 2, 3 and so on. We are going to get it this as the series. So let me just give you this one kind of thing here. So if n is equals to 1, we are going to get it a by z to the n is equals to 0 first. So at that time this a by z to the power 0, that is equals to 1, plus if n is equals to 1, at that time it would be a by z. If it is n is equals to 2, at that time it is a by z to the power 2. Again if it is a 3, n is 3, it is a by z to the power 3 and so on. So that means what, this is nothing but a series which is nothing but 1 minus z to the power minus 1. That means what it is in the cases z is nothing but a by z. We have already seen this type of, please reach to the previous sessions of from this I pattern of the Z transform, which is nothing but this. This can be written as 1 minus a by z to the power minus 1, and this can be written as instead of minus 1 we can write down that in the denominator 1 upon 1 minus a by z, that is adjusting the z, cross multiplying over here, and will be getting z upon z minus a of this particular Z transform of the function a to the power n, where is the a by mod of a by z is less than 1, that is mod of z is greater than mod of a, as the ROC region of convergence for this particular series or a function. Then Z transform of -1 to the power n is equals to z upon z plus 1. How can we do that? Because of this particular function, if I'll put a equals to -1, we are going to get this as Z transform of -1 to the power n as z upon z plus 1. And where is this mod of z is greater than 1, because of this mod of -1 is equals to 1, and we have got the ROC as mod of z is greater than 1. Moving ahead with the, so we have done with this, moving ahead with the e to the power at. So as I've told you, whenever we are going ahead with the n, we are going ahead with the sequence, and whenever we are going ahead with the at or a small t is nothing but a function. So it's Z transform of e to the power at. As I've told you, this has to be the power, this is nothing but, so t is nothing but is equals to n into capital T because of the periodicity. So Z transform of e to the power a and t is equals to Z transform of e to the power at to the power n, and then we can go ahead with the same what we have done it here so far, because this is because of this particular previous property which we have already discussed in the properties session, and therefore this is nothing but what we have done it here the same way what we can do it here. So e to the power at is so Z transform of e to the power at to the power n is nothing but z upon z minus e to the power at. So it's same as that what we have done it here so far. So this is nothing but, so this is nothing but the small a, what we can check it. So it is a to the power n, which is nothing but replacing this a with e to the power a capital T, and the ROC is mod of z is greater than mod of e to the power a into capital T. Again e to the power minus at would be same as that. Instead of this e to the power at, we have to write down here e to the power minus of at. That is what we have written here. This is what is the answer for this one, next one. Next is, now we have to use the time shifting property to go ahead with this particular question or this particular function a to the power n minus 1. Z transform of f of n minus n0 is equals to z to the power minus n0, z transform of f of n. This is what we have used it here. Z transform of a to the power n minus 1 is nothing but z to the power minus 1 into z to the power a to the power n. This is what we have used here, the property, and we know that z transform of a to the power n from this particular here is nothing but z upon z minus a. Z inverse is nothing but 1 by z, getting cancelled for this particular z inverse and z. We will be having the question answer as 1 upon z minus a if n is greater than or equals to 1. This is what all about this different function. I'm trying to fit all these functions in one go so that you will able to compare with them, and if I'll just try to erase it off, you will get the final, or you can say a clean view of all these functions and all the solutions of these functions in a one go. Because this is very important to understand how the standard functions are getting connected to each other, so that we can easily find out or use this particular standard function or Z transform of a standard function in the upcoming sessions. I hope you have understood this particular set of standard functions, Z transform of them. Thank you. Happy learning.